In this part 2 of exponential functions, graphing exponential functions, we're going to take a look at a form of the exponential function that has a couple extra pieces added to it. And these pieces are going to play a critical role in defining what our function ends up looking like. So what we're going to take a look at is exponential function with shifts, namely vertical and horizontal shifts. So we have this exponential function right here. What we saw before was y equals a times b to the x. So now what we have is we have a piece being subtracted from x, and then we have a piece that's being added to the end of the equation. So what we end up having here is something that is being added or subtracted onto the independent variable, and something that's being added or subtracted onto the entire equation. So h and k. Now we already have said that a was our initial value, that b is our base multiplier. H in this case is what we call our horizontal shift, and k is our vertical shift. And the equation y equals k is what we call our horizontal asymptote. Okay, so those are what we define them as, but how in the world do they work, how in the world do they operate, is the other question that we need to answer. So comparing that form to our first example here, y equals a times b to the x minus h plus k. Again, comparing that, what do we end up having? We end up having that a is equal to 2, b is equal to 3. We have what h is equal to. Now we have to be careful here. I'm not going to say negative 2 because it's already negative in the x minus h. So in the exponent piece, you almost have to think opposite. So instead of negative 2, h is actually 2. But with k, we can think the way we normally think, and k here would be negative 8. So we have our four constant values in this equation. A equals 2, b equals 3. That's our initial value and our base multiplier. H is equal to 2, which we saw up here was what's called a horizontal shift, and k is negative 8, which we saw was a vertical shift, but it's also what gets us what's called our horizontal asymptote. Okay, so here's how it operates when we have this reality in play of these things called vertical and horizontal shifts, and then also a horizontal asymptote. We saw in the previous examples that the equation leveled off at the x-axis. Whether it was growth or decay, it always leveled off right at the x-axis. Well, in this case, we're not going to level off at the x-axis anymore. We are going to level off at the value of k. Namely, we're going to level off at the equation y equals k. So for us, that would be y equals negative 8. So down here at negative 8, I'm going to draw a dashed line. Okay. And I'm going to label that dashed line y equals negative 8. Because y equals negative 8 is the equation of a horizontal line that goes through the point negative 8. Okay, so instead of the x-axis, this is the horizontal line that my equation is going to level off at. So in other words, everything has shifted down 8 units. That's why we also call the value of k our vertical shift. It's taken the whole equation and shifted it down 8 units. Okay. Now where we normally start is with our initial value, our y-intercept. For us, that's our a value of 2. So we might think that we put a value at 2, but we're not going to put a value there because, as you saw with that horizontal asymptote, the entire equation has shifted down negative 8. So I'm going to take that value and shift it down negative 8 as well. So another way to look at it is instead of being 2 above the x-axis, my value of a, my initial value, is 2 above my horizontal asymptote at y equals negative 8. But I'm not even going to put a point there because it doesn't exist there either because of our horizontal shift h. for us, that would be a 2. So because h is positive 2, we actually take this point, which we've already shifted down 8, we're going to shift it to the right 2 as well. And this is where that point exists. That point exists at that location rather than up at our initial value of 2 on the y-axis because of our vertical and horizontal shift h and k. So now it's from this point that I'm going to build my t-table. And taking a look back up at our equation, do we expect a growth or decay? Well, because our base multiplier b is greater than 1, we expect growth. So we should see some stuff to the left and right. So the point that we know exists on our graph is the point 2, -6. So I'm going to pick a couple other values. I'm going to pick 1 and 0 and 3 and 4 to get a general idea of what our graph looks like. So getting our calculator out, let's go ahead and plug some of these values in. And I gotta be careful here because of all that's going on in here. So I'm going to plug in 0 first. That's going to be a 2 times 3 to the 0 minus 2, and come back down minus 8. So 2 times 3 to the 0 minus 2 minus 8 is equal to negative 7.78, rounded off. Now I'm going to plug in 1. So that's 2 times 3 to the power of 1 minus 2, and then minus 8. That's going to give me a negative 7.33. Now I'm going to plug in 3. So that's going to be 2 times 3 to the power of, now I do want to make a point, in the TI-84 that I'm using, the exponent literally goes up into a superscript. If you're using a TI-83, you're going to have to make sure that you put your parenthesis around your exponent. So in this case, it's the parenthesis around 3, which is the x value we're plugging in, minus 2. Make sure, again, if you're using a TI-83 or any other scientific calculator, you're putting your exponent in parentheses. And minus 8. And there, I'm getting negative 2. And then let's plug in a 4. So that's 2 times 3 to the power of 4 minus 2 minus 8. And we're getting a 10. So we've got some points now that we can graph and connect the dots. So 410 is way up here. 3, negative 2, 2, negative 6, 1, negative 7.33, and 0, negative 7.78. So as you can see, just like we anticipated, our graph is going to come down and level off right at our horizontal asymptote of y equals negative 8. Great, so this is how you would graph and what it would end up looking like with these vertical and horizontal shifts. It's taken this equation, shifted it down, so instead of leveling off at the x-axis, we're leveling off at negative 8. And it's also shifted it to the right 2 units. So h and k, they don't change necessarily the look of it, they change the location of it. It still has the same look of an exponential equation, but it's been shifted around. Now, there's a couple things that we want to do with this. First thing is label our horizontal asymptote, which we already did. Second thing is we want to label our y-intercept. So our y-intercept here is the point 0, negative 7.78. Okay. What we also want to do is we want to label our domain and our range. Our domain and our range. Now this is unique because domain is how much we use up left to right. Where is our function confined left to right? Now I've got arrows on both sides of my equation, which indicate that our equation actually goes on forever and ever in both the negative x and positive x direction, meaning there is no boundary. There's no value of x that my function is always greater than or always less than. So our domain is actually everything. In mathematics, we say all real numbers. And to signify that, it's an R value that looks like the money symbol, but with an R instead of an S. That symbol right there means all real numbers. So that's what we're going to use to identify the domain of an exponential equation. What's interesting is all exponential equations have that as their domain. Now, what about the range? The range is our y value. All the y values we use up. Now, in an exponential equation, our horizontal asymptote right here serves as a boundary. Our equation is always above, in this case, our x, or that horizontal asymptote. So in other words, my range, which is all my y values, is always greater than -8. My function is never below -8, and also not never equal to -8. So that's why I wrote y is greater than, not greater than or equal to, but greater than -8. Excuse me. So let's go ahead and take a look at another example. Here's another example that we're going to take a look at. Let's compare this to the form that we saw. Y is equal to a times b to the x minus h plus k. In this example, our a value is -4, our b value is a 2, our h value is, and we got to think opposite, negative is already there, so h value is actually 3, and our k value is a +6. So there's my values for a, b, h, and k. Now, just like in the example we saw, we're going to start from our new leveling off point, our new horizontal asymptote. We saw that our horizontal asymptote is the line y equals k. So for us, that's y equals 6. So up at y equals 6, I'm going to draw a horizontal line at y equals 6. So that's going to be my leveling off point. Okay, so we're going to have something a little interesting happen here. Okay. The interesting piece that's going to happen here is this. Our initial value of a says that it's at -4. -4. This is the first time we've seen a negative initial value. This is going to do something to our equation that we haven't seen yet before. So it says our initial value is -4. So I'm going to go down to my x-axis at -4. I'm going to put an x there because I know that's where I start, but my point actually doesn't exist there because of my vertical and horizontal shifts. My vertical shift is k, and that's 6. So I'm going to go up 1, 2, 3, 4, 5, and 6. Okay. So again, instead of 4 under the x-axis, I'm 4 underneath -4. I'm down 4 from my horizontal asymptote. But I also have a horizontal shift of h equals 3. So from here, I'm going to go over 3, and this is the point at which my graph exists. That's the point at which my graph exists. Okay, so it's from that point, which looks like it's at 3, 2. So if I go x, y, t table, I'm going to go 3, 2. I'm going to look at some points to the left, and I'm going to look at some points to the right. I'm going to look at 2, 1, and 0. I'm going to go all the way down to 0 because I know I need to find my y-intercept. And then I'm going to go 3, maybe 4, and 5. Okay, so those are the x values so that I can see what's happening on both sides of that point that we know exists on our graph. So let's see what's happening. Okay, let's plug in 0 first. So that's going to be -4 times 2 to the 0 minus 3 plus 6. And I'm getting a 5.5. Now let's plug in a 1. That's negative 4 times 2 to the 1 minus 3 plus 6. I'm getting a 5. I'm going to plug in 2. So that's negative 4 times 2 to the 2 minus 3 plus 6. I'm getting a 4. Okay. Now I'm plugging in 4 for x. So that's going to be a negative 4 times 2 to the power of 4 minus 3 plus 6. I'm getting a negative 2. Okay. And then last but not least, I've got a negative 4 times 2 to the power of 5, to the power of 5 minus 3 plus 6. I'm getting a negative 10. So with those values, let's plot them and see what we end up with. So 0, 5.5 is right here. I've got 1, 5, 3, 2, 2, 4, and then 3, 2, and then 4, negative 2, and 5, negative 10. So what we actually have happening here is that we're still leveling off here, but instead of being on the top side of our horizontal asymptote, we're actually on the bottom side. So it's as if the exponential equation has flopped over down to the bottom side of our horizontal asymptote. Still follows the pattern of an exponential curve, but because our value of a is negative, it's underneath instead of above. Now I can, I've already labeled my horizontal asymptote. I can label my y-intercept of 0, 5.5, and I can also talk about the domain and range of this function. Domain, as we've said, of any exponential function is all real numbers because it goes forever in the left and right hand direction. However, a range, in this case, 6 serves as that vertical boundary. My graph never goes above the value of 6. In fact, it never equals the value of 6. So I can say for my range that y is always less than 6. My graph is always less than the y value of 6. So there's exponential equations with vertical and horizontal shifts, and a new leveling off point, which we call a horizontal asymptote, and then also discussing the domain and range. And in this last example, what happens when our a value is negative.